Hi everyone, in this video tutorial we're going to go into a little bit more depth on how to name substituents. Remember that substituents are atoms or groups that extend off the parent hydrocarbon, our longest continuous chain. Substituents are each assigned a locant, and in a former video we talked about how to number that parent hydrocarbon, right? And that locant will precede the name of the substituent separated by a dash pictured down here in the left. Now, substituents need to be named in alphabetical order, and there is no space between the last name substituent. Take a look at here at the middle of your screen. There is no space between the last name substituent and the parent hydrocarbon with the functional group ending. And then what we're going to do is, if multiple of the same type of substituent are present, we are going to denote the number of those substituents using the prefixes di, tri, tetra, or penta. And these substituents would all be named together with the locant specifying, or locants I should say, specifying each of those substituents in a row separated by commas. So you might have something like 3 methyl groups in a molecule, and 2 of them might be at the 3 and 1 is at the 4, so we'll say 3, 3, 4 dash trimethyl hexane. We list all of the numbers in a row and then say trimethyl. Okay, we'll go over a couple more examples. Now, we've mentioned this briefly in another video, but we use this suffix "-il" to denote that a carbon group, an alkyl group, is a substituent off a parent hydrocarbon. So this is alkyl substituent nomenclature. So if you have a 1-carbon substituent, we call that a methyl group. If you have a 2-carbon substituent, we call that an ethyl group. If you have a 4-carbon substituent, it's a butyl group, and a 5-carbon substituent is a pentyl group. So get used to seeing that suffix "-il", Y-L, that denotes that something is a substituent. We're going to go over that real quick, and then we're going to talk about halogen substituents, and then in a subsequent video, we will talk about certain common name substituents. So let's go into alkyl substituents. Here you have a hydrocarbon that is 6 carbons in length. At the 2 position, there's a branch, and it's a 1-carbon substituent. Therefore, we say that substituent is located at the 2 position, and it is a methyl group, a 1-carbon substituent. In our next example, we have, again, a 6-carbon chain, but it's now at the 2 and the 3 position, that we have these methyl groups. Therefore, we will use the prefix di to denote that there's 2 methyls, and we will number and list those locants of the locations of the methyl groups prior to saying dimethyl. So we say 2, 3 dash dimethyl hexane to denote those substituents. We have multiple of the same type. And we mentioned this briefly before. Here's another 6-carbon chain. And what we're going to do is number in the direction that would give the overall lowest locant set. So let's just reiterate that for a second. If you numbered in this direction, you would have the locant set 3, 4, 4. However, that would be a larger locant set than numbering in this direction, which would be the correct locant set, because you have then 3, 3, 4, which takes precedence over 3, 4, 4 as a locant set. There are now 3 methyls. We'll list all of those locants in a row. 3, 3, 4 trimethyl hexane. Okay? And then here's just a couple more examples. You have here now a 7-membered chain. And we are going to number in this direction 1, 2, 3, 4 to give a 3, 4 locant set, as opposed to in the other direction, if you numbered in this direction, you would have a 4, 5 locant set. So that would not be our locant set. We want the 3, 4 locant set, and we have a 2-carbon substituent and a 1-carbon substituent. The ethyl group is named first because it is the first alphabetized substituent. We'd say 4-ethyl 3-methyl heptane. And in our last example, we have a more complex molecule here. We are going to number the chain in the direction that gives the overall lowest locant set, which would be this numbering. And we have a methyl group, we have an ethyl group, and a propyl group. Propyl, again, means 3 carbons. And we will list those substituents in alphabetical order. So recall that the numbers may jump up and down a little bit, and that's totally okay. In the IUPAC system, we have to name those substituents in alphabetical order. Okay, so that's our nomenclature for alkyl substituents. Now, remember, halogens are considered to be a functional group alkyl halides, but in the IUPAC system, these alkyl halides are just considered substituents. They don't actually have a functional group priority. And when we have halogen substituents, we are going to denote those by using the prefixes fluoro, chloro, bromo, and iodo, respectively, for fluorine, chlorine, bromine, and iodine. So let's take a look at some examples. Here we have 2-fluorohexane, and it's at the 2 position that we have this fluorine. In our next example, we have both a chlorine and a bromine, and we would number the chain in this direction. And we will name the bromine first. It is the first alphabetized substituent. We have 3-bromo-2-chlorohexane. In this next molecule, we have 2 bromines and 1 iodine. And we would number in the direction to give the overall lowest locant set, which would be 1, 2, 3, 4, 5, 6, giving us a 3, 3, 4 locant set. And the incorrect numbering would be this. Be 1, 2, 3, 4, because then you would have 3, 4, 4, so not the correct locant set. The blue numbering is the correct locant set. You would then say, let's name the bromines first, and what's interesting here is di is actually not considered for alphabetization, and we're going to be talking about that in another video, but those prefixes di, tri, tetra, sec, and tert are not considered when you alphabetize. Therefore, it is actually the B that we are considering. So we say 3, 3 dibromo 4 iodo to denote the iodine, hexane. And here is just a couple more examples. I want you to talk yourself through these examples. Okay, so it's really important that first and foremost, right, we have our foundations down of identifying the parent hydrocarbon and then numbering that parent hydrocarbon, because those 2 components are crucial to being able to then identify the right substituents and assign the correct locants. The biggest mistakes I see in IUPAC nomenclature is that students will mess up the numbering. And so if you're having any trouble with the numbering, go back and watch my video on how to number the parent hydrocarbon, because that is so crucial. Because once you can get that down, it's really not too hard to identify those substituents coming off the parent hydrocarbon. And remember, if it's an alkyl substituent, kind of a simple straight chain alkyl substituent, we just use the suffix -il to denote that the group is a substituent off the parent hydrocarbon, and we use fluoro, chloro, bromo, and iodo to represent fluorine, chlorine, bromine, and iodine in the molecule.